Picture this: a farmer stands in a field, not with a hoe in hand, but with a tablet, orchestrating a symphony of sensors, drones, and AI-powered insights. This isn't science fiction, it's the cutting edge of modern agriculture, where big data is revolutionizing the way we grow our food. In a world hungry for sustainable solutions, smart farming isn't just an option. It's our future. Welcome to the Fields of Innovation YouTube channel, where smart farming starts here. Discover the future of agriculture. Today, we're diving deep into the world of big data in agriculture, exploring how this technological marvel is transforming farms into data-driven powerhouses of productivity. Big data is no longer a luxury, it has become a necessity in modern agriculture. With the world's population projected to reach nearly 10 billion by 2050, the demand for food is rising faster than traditional farming methods can sustain. Farmers face unpredictable weather, shrinking arable land, and increasing pressure to produce more with fewer resources. This is where big data steps in. By collecting and analyzing massive amounts of information, farmers can make smarter, faster, and more accurate decisions. Big data turns farming from a business based on intuition into one driven by evidence and predictive insights. But what exactly is big data in agriculture? It's far more than simple farm records or yield tracking. Big data in agriculture refers to the use of large, complex datasets to improve farming decisions. It integrates information from multiple sources, creating a comprehensive picture of the farm ecosystem. Imagine sensors and IoT devices placed strategically in soil and equipment, constantly tracking moisture levels, nutrient content, and machinery performance. Picture drones and satellites capturing high-resolution images of crops, detecting plant stress before it's visible to the naked eye. Add to this mix detailed weather data that helps anticipate rainfall, droughts, or frost, and market data providing insights on pricing trends, consumer demand, and global supply chain dynamics. Together, these streams of information create a data ecosystem that allows farmers to act proactively rather than reactively, staying one step ahead of nature's challenges. The impact of big data on productivity is nothing short of revolutionary. It directly translates into higher yields and lower costs through several key pathways. Precision agriculture, powered by data, allows farmers to apply the right amount of water, fertilizer, and pesticides exactly where needed. Gone are the days of treating an entire field uniformly. Now, each plot or even each plant receives tailored care, avoiding waste and minimizing environmental impact. Predictive analytics take farming to the next level, enabling farmers to forecast future crop yields, predict pest outbreaks, and even anticipate shifts in market demand. This foresight is invaluable for planning planting schedules, optimizing harvest times, and selling crops at the most profitable moment. Moreover, advanced algorithms can detect unusual patterns in crop health data, identifying the early stages of disease or pest infestations. This early warning system allows for rapid, targeted intervention before problems spread across the farm, saving crops and reducing the need for widespread pesticide use. The technologies powering this data-driven agricultural revolution are as impressive as their impact. IoT devices and sensors form the foundation, continuously collecting real-time data about soil conditions, crop health, and equipment performance. These smart sensors can detect when a crop needs water or when soil nutrients are depleted, sending alerts directly to farmers' smartphones. Machine learning and AI algorithms process these vast volumes of farm data, identifying patterns and making predictions that would be impossible for humans to calculate quickly. For example, AI can recommend optimal planting schedules or predict the spread of a plant disease with uncanny accuracy. Cloud computing and farm management platforms make all this possible without requiring farmers to invest in expensive hardware. These cloud-based solutions provide accessible dashboards for decision-making and foster collaboration among farmers, agronomists, and researchers, creating a network of shared knowledge and expertise. Real-world examples demonstrate the tangible impact of big data in agriculture. In the United States, large corn producers are using predictive analytics to determine the optimal planting times and fertilizer use, significantly increasing yields while lowering costs. Across the Pacific, Australian farms are deploying IoT-enabled irrigation systems that adjust water use based on soil moisture and weather forecasts, saving millions of liters of water annually in a country where water scarcity is a critical issue. In the United Kingdom, advanced sensor-driven automation in greenhouses allows for precise control of temperature, humidity, and light. This data-driven management results in consistent high-quality crop production year-round, even in a climate not naturally suited for certain crops. These case studies prove that big data is not just a theory, it's a practical, proven method that is reshaping agriculture worldwide. However, the path to widespread adoption of big data in farming is not without its challenges. Data privacy and ownership remain sensitive and unresolved issues. Who owns the data collected by machines, sensors, and platforms? the farmer, or the tech provider? This question has significant implications for farmers' autonomy and the potential monetization of agricultural data. Additionally, the high adoption costs of advanced technologies can be a barrier, especially for small-scale farmers. Without subsidies or partnerships, the benefits of big data might remain limited to larger farms with more capital to invest. Perhaps most critically, there's a need for farmer education and improved digital literacy. Data is only valuable if farmers know how to interpret and act on it, and many need training in digital tools to fully benefit from big data's potential. Addressing these barriers is essential to making big data accessible and equitable across the agricultural sector. Looking to the future, several trends will define the next generation of data-driven agriculture. Blockchain technology, combined with farm data, promises to create unalterable records of a crop's journey from seed to shelf, meeting the growing consumer demand for transparency in food production. As climate change disrupts traditional weather patterns, AI-driven models will become increasingly crucial in helping farmers adapt their planting schedules, crop varieties, and irrigation practices. The future of agriculture is not just about individual farm efficiency, but global collaboration. The sharing of data across borders can help predict global food supply risks, reduce food waste, and strengthen food security worldwide. This vision of the future is not just about technology, but about collaboration and sustainability powered by data. In conclusion, big data is revolutionizing agriculture by making farming smarter, more efficient, and more sustainable. From precision agriculture to AI-driven predictions, data allows farmers to increase productivity while conserving resources. The journey towards fully data-driven agriculture is not without challenges, but the potential benefits far outweigh the risks. By embracing data, farmers become innovators and stewards of the future food system, capable of meeting the world's growing food demands while preserving our planet's resources. If you found this video insightful, please leave your questions in the comments and subscribe to stay updated on the latest in farming technology and innovation. Together, we can shape the future of agriculture, one data point at a time. Remember, in the fields of tomorrow, knowledge isn't just power, it's the seed of sustainable abundance.